Hey, what's going on, guys? Let's do this problem right here. Here this question is asking, given T naught is equivalent to 95 degree Celsius. So here we have to have a Celsius right here. So 95 degrees Celsius and cools to 80 degrees Celsius in 30 seconds. How much time will it take to cool to 65 degrees Celsius from 80 degrees Celsius? Now to find this one out, we are going to use Newton's law of cooling. According to Newton's law of cooling, Q dot is equal to Ka T minus Tr. So here this temperature minus room temperature. So we need to have room temperature right here. So let's say that is 20 degrees Celsius. So Tr is equivalent to 20 degrees Celsius. Right? Now we know that dq is equivalent to mc dt. So we can replace this dq with mc dt over dt. That's equivalent to Ka T minus Tr. Now, in order to integrate this one, it's better to arrange the like terms together. So that's why we arranged these temperatures together and time to the other side. Now here we have to integrate this one, right? And also we don't have any of this value. We don't have thermal conductivity, area, mass, or C value. Now in this case, what we can do is we can take all of this together as a constant and solve this problem. So if I write this one, so let's say this is a C value. Let's call this one C1. Now let's go ahead and integrate this one. So this is going to be going from T naught to T final, and here we are going to have dt over T minus Tr, and in the other side we are going to have Ka. So let's call this one C1. So this is a constant right here, and then integrate dt. So the time is going from 0 to t. That's going to be our time, and let's simplify this one. If you integrate this one, this is going to give you ln of t minus tr, and that's going from initial temperature to final temperature. And in the other side we have C1. If I integrate this dt, that's going to give us t right here. So we are going to have t, and we know the time that's provided in the question, that is 30 seconds. So we can apply this 30 seconds right here. So instead of writing t, maybe I do that in next step. So this is t, and let's simplify this one. Ln. So this temperature, I'm dealing with the first part right here, 95 and 80. So when you plug 90 right here, 90 minus 20, that's going to give you 75. So this is going to be ln 75 when you apply for the final value. So actually final should be final is 80, right? So 80 minus 20, that's going to be 60. So here we are going to have 60 right here. This is ln 60 minus, this is degrees Celsius, ln 60 degrees Celsius minus, then ln, the initial value is 95, 95 minus room temperature, that's 20, that's going to give us 75. So here we are going to have 75 degrees Celsius. And in the other side we have this constant times the time, that is 30 seconds. It's in the question. So this is going to be C1 times 30 seconds. And when we subtract ln values, that can be expressed as ln 60 over 75, right? 60 over 75. Since we have the denominator higher value, we are going to have the ratio less than 1. So this is going to be a negative value. And let's look at the other side. We are going to have 30 C1, right? So let's keep the second for a unit to find the final unit. 30 seconds, and here this degree Celsius cancels, so we don't have to put the unit. So this is 30 seconds right here. So we are trying to solve for C1. C1 is going to be equivalent to ln 60 over 75, and if you calculate that value, let's put them together and calculate, right? So ln 60 over 75 over this 30 seconds. And if you calculate this one, you should get negative 0.007438 per second. This negative is due to this Laun ratio because 60/75 is less than 1. So that's why we get a negative value right here. Now this is not our question. Our question is how much time will it take to cool to 65 degrees Celsius from 80 degrees Celsius. So this information is needed to solve this problem. That's why we solve this one. We need this constant in order to solve this problem because we don't have this KAMC values. So that's why we found out this value, and then we can do the same thing for this one and substitute these values, right? So in order to do this question, again we need this equation, this bottom equation, we need that one. So let's get rid of this top part and continue this one right here. Here we are going to have again, we are going to integrate this one. If you integrate, you will end up with this one right here. So we also don't need this part right here. We can erase this part too. So this is the only part we are going to deal with. Now, so in this case, final temperature is going to be 65 degrees Celsius, right? Because it's going from 80 degrees Celsius to 65 degrees Celsius. So initially we are going to, so final is going to be 80. Final is going to be 65 right here. So 65 minus 20, that's going to be 45. So this is going to be 45 minus Laun, then initial is 80, so 80 minus 20 is going to be 60. Here we are going to have 60. So this is going to be our Laun values, and in the other side we are going to have C1. Time is going to remain the same. That's going to be, time is what we are trying to find, how much time it will take. Okay, C1 times T. Now let's solve our time. So let's express this one in better way first. This can be expressed as Laun 45 over 60. Again, if you notice, 45 numerator is smaller, denominator is higher, so we are going to have a ratio that's less than 1. So this is also going to be negative. And here in the other side we are going to have C1T. Here we are trying to solve for T. T is going to be equivalent to Laun of 45 over 60 over C1. Now instead of C1 we can plug this value. We found out this one already. That is negative 0.007438 per second. And if you solve for this one, you should get 38.7 seconds. And that's gonna be that's how much time it will take to cool this one from 80 to 65 degrees Celsius. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.